Hey, and welcome to the Healthcare.ai broadcast. It's been a while.
Sure has.
It's great to be back. We've got Mike Levy, and I'm Mike Mastanduno. Today we're going to be talking about something very exciting, which is that we finally let Mike out of the basement where he's been refactoring the package. And
I did enough work to get out of the basement.
Yeah, you did.
That's nice of you.
You know, the package looks really good. It's got a lot of great functionality. It's easier to use, more robust under the hood, and more healthcare specific. So I know you're excited to show it off. I sure am too. You know, you're watching this, so you're on YouTube already, but you can log into YouTube, and I'll be monitoring the chat so we can answer your questions right on the air here. We're going to be showing a demo of the new package and the new docs website, both of which look great. If you can't see text, you can use the gear in the lower right to up your resolution to 1080p, and you should be able to see a little bit better. And then you can like and subscribe. You'll get updates about this broadcast, future broadcasts, and be able to come see the chat. We also have a Slack community, if you haven't forgotten. There's over 800 people in there now, and there's a lot of discussion about healthcare data, machine learning. It's a great place to get help from people like yourself. So hope to see you in there. And then the final thing is that this September, again, we've got another hands-on machine learning training in person in Salt Lake at the Healthcare Analytics Summit. Mike's going to be teaching a day-and-a-half long course, and last year's was a huge success. I think this year's is going to be even better. Do you want to say something about it, Mike?
Yeah, so it'll be Monday, September 10th and Tuesday, September 11th, so just before the actual Healthcare Analytics Summit. We're going to do a half a day on R for healthcare analytics, and in that you'll learn everything you need to know about R in order to do machine learning, and then we'll do a full day on machine learning, hands-on. You can bring your own data. We'll train models, make predictions, talk about what makes a good machine learning use case. It should be really fun.
Cool, that sounds great.
So again, that's hasummit.com if you're ready to sign up for that.
And I know it sold out last year, so it was one of the most popular trainings, wasn't it?
I think so. Folks seem to be interested in machine learning.
Yeah, they do. Yeah. All right, so what's on the agenda today?
So we had one article from the literature on machine learning that we wanted to talk about. This is from the British Medical Journal, and it's titled Biases in Electronic Health Record Data Due to Processes Within the Healthcare System, Retrospective Observational Study, which is not as sexy as the findings that they came up with in this article.
That's a mouthful.
Yeah. So the sort of one-sentence summary is that they took labs for patients and trained models using either the results of the lab or the timestamp from when the lab was ordered. And they found that the timestamp had more information. It generated more accurate predictions than using the lab results. Which on the face of it...
That's kind of perplexing. Like, why would that be?
Yeah, so I think what's happening... So first of all, in my models, I often just use the presence of a lab as a feature.
Okay.
Right? If a patient has had, say, chest x-rays, we know a lot about that patient just from that. So that just 1-0 had chest x-rays can be an informative feature. Mm-hmm. What they've done is added features like hour of day and day of week to that, which makes sense that carries additional information, right? If you had chest x-rays at 3 in the morning, then we know quite a bit about you. And it's not terribly surprising that we can predict things like your mortality or the total cost of your stay from that.
So you're saying that having chest x-rays at 3 a.m. might be worse than having chest x-rays at noon,
Totally.
For instance.
Yeah, it gives you additional information.
And that's what they found in the paper.
And that's what they found. I think one caveat here is that they, as I understand it, they build a baseline model that contains only the patient's age, sex, and race. Mm-hmm. And then they add one at a time each lab and either the timestamp information or the lab result information. Mm-hmm. So age, sex, and race and white blood cell count, or age, sex, and race and chest x-rays. And I think there's probably more information in the first timestamp than in additional timestamps. Whereas if you were... So from your chest x-rays at 3 a.m., we know maybe that you're an ED patient, right? That you were seen in the emergency room or that there's some emergency going on. Learning then that you had a bunch of other tests at 3 in the morning is probably not going to add a bunch of additional value. Whereas if we found out that your chest x-ray was abnormal, all those other tests that you had would then provide additional value and could be more informative features. So I'd like to see some follow-up here and see if they train a model on all of these features with either the timestamps or the test results, how do they compare then?
Well, I regret to inform you that the paper's already published, but
Yeah.
maybe BMJ would take a letter to the
supplemental
editor.
review.
Yeah, supplemental review.
Maybe I'll write to the authors and see if they'd be willing to share their data. We could play around with
That
it
would
in
be
Healthcare
cool.
AI.
Yeah. So what does it mean for us building machine learning models?
Yeah, so it's good news for us. It means that our job is easier, right? We don't need to take the results of a white blood cell count test and parse whether they're high or low or normal and how that changes with the patient. We can just take the timestamp feature of that test, pull out the hour and the day of the week, and boom, we have informative features and we're off to the races.
That's fascinating because I feel like traditional healthcare analytics are all about this deciding where the clinicians say
Totally.
the threshold of high or abnormal is,
Yep.
and we're saying like it doesn't even matter.
We can roll right over that.
Yeah.
Yep.
Well, that's pretty cool.
It was pretty cool.
Well, all
So
right then.
if you train models with features engineered from timestamps, please let us know how that goes.
That would be good.
Be curious to find out.
Should we jump to the unveiling of the new package?
Let's do it.
All right. So, yeah, we're really excited. We've got a brand new documentation website that looks beautiful. It was built automatically with Package Down, which is a very awesome R package. Do you know who wrote that?
Yeah, I think it was Hadley's team. At
Is
our
it
studio.
Hadley? Yeah, okay. That makes a lot of sense.
Yeah.
Seems like everything great comes out of Hadley's team. But the website looks great,
Thanks, Mike. Yeah, so this is the website. It's rendered entirely from our Markdown and from the Roxygen documentation from within the package for you package developers out there. And we get this really, really nice looking site. So let me just walk you through sort of the overview of the site. This is meant to be the main hub for when you want to figure out how to use Healthcare AI, you want some examples, you want to know some details about a function. This website is really the place to go.
You still get the help files in the R package in our studio, though, right?
Yes, and you get them on the website with the example code run, and we'll get there in just a second.
Cool. Okay.
So we have some overview, some high-level information here on the front page. We'll walk through this in a bit, but this is how easy it is now to train machine learning models. So we have our data set here, an identification column, and we want to predict the outcome diabetes. And with this one line of code, we're preparing the data, doing things like imputation, generating some new features, doing some feature engineering, tuning multiple algorithms over a wide array of hyperparameters, and identifying the model that will make the most accurate predictions in deployment. All in one line.
That's quite a line. It must be
it's
a
a big
lot.
line.
It must be a lot buried under there.
Yeah, so what we're trying to do is put all of that under the hood. And if you don't want to worry about all that, if you don't know what imputation means or you don't want to fuss with imputation, you don't have to, right? It's all hidden away. It all just works automatically. Now, if you know what imputation is and you know that you want to use KNN imputation instead of mean imputation for numeric variables, there are different levels at which you can interact with the package. So you can go and look at the prep data function or the impute function if you want to fine-tune how you're doing imputation, but you don't have to.
I think from a big picture standpoint, one of the coolest things about this package is that you've translated it to use a much more R architecture. We use these S3 classes, which are pretty common across R, and it handles unquoted variable names, which is pretty much how the tidyverse works. So it's much more compatible with R, and then you'll find that a lot of the functions and objects have predict methods, print methods, summary methods. It behaves like our code should.
Right. We've tried to make it intuitive so that functions just sort of work the way you might expect them to, and you can often even guess at what a function will do and give it a shot and see if it works, and hopefully it will work as you expect. So here's an example of that. So we've trained our models up here with this machine learn line, and then we have our models object. And if we just enter the name of that, we get some summary information about the model. So we trained here a random forest and a k-nearest neighbors. We did some cross-validation. Here are a couple of performance metrics. I'll zoom in just a little bit more. That text is a little small. And then here's how we do prediction. So all we have to do to make predictions, here we're predicting on the training data set, is to say predict models. And whether it's a classification algorithm or a regression algorithm or Any other details, predict your model's object is all you need to know. And then, like Mike was just saying, we have plot methods defined for a lot of objects. So you can call plot on your predictions, and you'll get a plot of your predictions. And that works whether it's a regression algorithm or a classification algorithm. You can also call plot on the model's object. You can call summary on the models or the predictions, etc. That's the high-level view. You have anything you want to add to that?
Yeah, so I guess, well, let me ask you a question about it. So the training a model we've seen is just one line. Generating predictions on, well, that's on the training data. Is it just a different parameter to use new data?
Exactly. So if you had a new data set that you want to make predictions on, maybe
Yeah.
it's just one line, you want to predict for an individual patient, or a whole bunch of lines, that would then be the second argument to predict.
And what about all the data prep and predict?
Happens automatically.
In the same way that it does in the training?
In an identical way to how it happens in training.
That's pretty cool.
So we have a bit of experience doing machine learning in healthcare, and one of the common problems that we keep bumping into over and over again is that the analyst does a bunch of data manipulation getting ready to build a model, and that's stored in some smattering of scripts, and maybe they kind of remember what they did. Then you have to do exactly the same data transformations before you make predictions in deployment.
Right.
But
Yeah.
you need that to happen on a production server, right? So that has to be that's a highly controlled environment. You can't have an analyst in there doing that stuff manually.
Yeah, and it happens could happen hourly or even minutely.
Or even in real time, right? You get an HL7 message that some new piece of data has arrived. You want to make that prediction. You need to be able to transform the data in the same way. And say you have missingness in that data that's just come in, you need to be able to impute values for that missingness in order to generate a prediction. So what we've done here, and Mike did a bunch of work on this. Don't let him sell himself short.
I appreciate it.
We create a data recipe. So in the machine learn step, we teach Healthcare.ai how to adjust Pima diabetes, the data frame, to get ready for model training. And we attach that recipe to the model object so that then when you make predictions, that same transformation happens and it all happens automatically. You just don't have to worry about it.
That's really amazing. So that's definitely something I'm super excited about in the new package.
I'm excited to use it. It just makes my life easier when I'm working on client data.
You know what I really worry about? Is I worry when on the sad day when I decide I'm not going to be working here anymore, I'm going to have to go interview, and I'm going to look ridiculous because I don't know any other machine learning packages.
I would use Healthcare.ai.
Yeah, exactly. It's like, what about data prep? Oh, it does it all for me. Okay, so one other thing with the Docs website. Kind of the elephant in the room, right, is that anybody can use scikit-learn or Carrot to build a machine learning model and even generate predictions on it using it. So what have we done to put these things in production? Does it help with databases anymore?
It does. So we have 4 vignettes currently, and we're building out more of these, but we have 4 sort of walkthroughs of common use cases for the package.
Okay.
And one of them is titled Database Connections.
Ooh, fitting name.
Yeah. And
it's almost like it was a leading question.
totally. And since you wrote this, Mike, maybe I'll let you walk through it.
Sure, I'd love to. Yeah, so I guess database connections. Man, that makes me look like I just wanted to talk, doesn't it?
It's good functionality. Mike, can you tell us about database connections in
thanks.
Healthcare.ai?
Oh, I'd love to. So database connections in Healthcare.ai, we found 3 pain points. The first is connecting to the database. I can never remember how to build those stupid connection strings.
Totally.
So we built a function that helps you build your connection string using parameters that you're used to seeing in R. It's called build connection string. You can feed it as little as just a server name, and it'll take care of the rest, assuming you're on SQL Server, which most people in healthcare are. If you're not, it can still handle other things. You just have to read the docs and check out how to do it. So that gets you connected. The new version of RStudio has this super intuitive, really nice way to browse through databases. And so after you've connected to the database within RStudio, you can browse through it. You can preview tables. You can see what's there, what column types are. It's really
It's like
pleasant to use.
SSMS right in your RStudio.
Yeah, it's awesome. So kudos to Hadley and team for that. I had a chance to take a class with Edgar Ruiz, who is a big part of the database functionality, and it's really impressive. So you can even use it to write dplyr code and query SQL tables. which is awesome. I would definitely recommend checking that out. But that gets you data in. You can do all your computations. You just need those 2 lines.
And just to be clear,
Yeah.
so you can use dplyr code or you can use SQL code in R with the package.
Right.
If you're more familiar writing SQL queries, you can use those in R to pull data from the database.
Yep. And it's as simple as this function dbRead. You just feed it your connection and your SQL query, and it'll bring you back your data. But there's a whole bunch more you can do if you want to go under the surface. So we talk about a couple of common ways to get data from the database, and then the last one is writing data. So the vignette has some strikes-throughs because there's a bug in the underlying package that does it, but we've got the workaround for you, so you can see how to write data to the database. And eventually we'll wrap this up in a really nice function called write data.
Just waiting for Jim Hester to do a little more work on one of his thousands of open source projects.
So Jim, if you're listening, we'd love it. We understand you're
issue
busy.
number 764 in the DBI.
You can just look for my daily requests, daily emoji pings. So that's really cool. I love the new, I love the website. It looks great. It's so easy to, when you publish some new documents or a new function, it builds itself.
Yeah.
It goes right to the website. It's so nice to use.
And I still use it when I need to remember what an argument is called for a function. I have it bookmarked here in Chrome, and I use it all the time.
Yeah, it just comes here. It's pretty great.
So let me show a couple more things here. So that's the database connections vignette. This getting started vignette is a walkthrough of all the sort of core functionality of the package. It's a great place to get started, as the name suggests. And then this functions page has all the documentation for all the key functions in the package. So we talked about that machine learning function earlier. If you want to learn more about it, you can pull it up here. And this will look familiar to you R folks as R documentation, right? So we have all of our arguments, the response, some details, and then examples. And I tell these examples not to run because it takes a little bit of time to train 100 models, as this function does. So these don't run. But for other functions, let me show you one that does. Maybe
Missingness?
Yeah, we'll get there. So this is the help page for plotting models. So if you do plot of your model object, the thing that comes back from machine learn, you'll get this. You'll get information about model performance in cross-validation. So how well different hyperparameters performed for your selected metric. Mm-hmm. But what I wanted to point out here is that the examples run, and so you can see the output of the examples here in the web page.
You don't have to copy and paste and run them, and that's nice. I like it.
But when you're ready to take the code and modify it for your own use, hop on over to RStudio, and let's dig in. So the package is on CRAN, so to install, you would do as normal, install packages, Healthcare.ai, or you can come up here and do tools, install packages, and select Healthcare.ai. That will give you version 2.0.0 of the package. I already have it installed, so I don't need to do that. And then we'll load it up with library Healthcare.ai.
So far, it's the same, right?
So far the same.
Okay.
The similarities are about to end.
All right.
So it started up. We get this little welcome message, pointed to two of our key locations on the internet. And then, boy, where should we start? How about our example data set?
Yeah, load the example data.
So we built in this example data set called Pima Diabetes. It's a data set of diabetes among Pima Native American women. And it has, you can see these predictors, so it has the number of pregnancies that the woman has had, their plasma glucose levels, some other details. And then this outcome column, diabetes, which isn't getting printed, so I will just do this. Show you the beginning of that. So our outcome column is a binary yes/no variable, so we can easily do. Whoops, I'm in the habit of saving every time I enter a new command. So we can do classification problems on this data set to predict whether each woman will have diabetes or not. So you mentioned the missingness function.
Yeah.
Let's go ahead and take a look at that. So missingness of human diabetes returns a data frame that tells us what % of the rows of each variable are missing. So we can see here that we have an ID for all of our women. We have an outcome. We have a diabetes yes/no call for each person. But we do have some missingness in some of those predictors. Now, here is the hopefully intuitive part that Mike was talking about earlier. So this is the piping operation. So I'm going to take the output of missingness and pass it through to plot. And we get a plot of missingness. So we can see insulin we had almost half missing, and insulin we have almost half missing. And there are lots of things in the package that you can just call plot on and get an informative plot of that object.
I'd say that's easier to use.
Yeah, so when in doubt, try plotting.
Okay.
What else should we do?
I think we should build a model.
All right,
I
let's
want
do
to see
it.
it.
So, okay, so at the highest level, right, for those of you who don't want to get your hands any dirtier than necessary, you just want a machine learning model as quick as you can, this will build you a pretty good one. This will use cross-validation to select optimal hyperparameters. It'll train multiple algorithms, do all that data prep stuff we talked about earlier. And it's as easy as this. It has 3 required components. So one is the name of the data frame. Then the second argument, it's a little small here. I imagine that'll be tough to read over YouTube. But the second argument is ... And what goes in there is any columns that you want to ignore.
Okay.
So any columns that aren't informative for the algorithm, you want to put in there, particularly identifier columns, right? So here that's patient_ID. And then the other thing that we have to supply is the outcome. So we'll say outcome equals diabetes. Actually, maybe let's do something different here. We saw a diabetes model earlier. Let's predict plasma glucose levels.
We did mention this earlier, but usually a lot of times our code, these names have to be quoted. Why are you not using quotes here? Is that intentional?
Through the plasma glucose has missingness in it. I can't do that.
Okay.
What doesn't have missingness?
Pregnancies, it looks like.
I think pregnancy, you're right. Yeah, let's see if we can predict how many pregnancies each person has had. So while that's training, you don't have to quote variable names because we use the magic of non-standard evaluation under the hood. So this, if you use the dplyr or ggplot packages, this will be familiar to you. You just provide the bare name of the column, like this to the function, and things work under the hood. Yeah. Likewise, if you use the formula function in base R, right, that also uses non-standard evaluation. Most of these things will work if you quote the column. If you say you had pregnancies in a variable and you wanted to pass that variable in, you might be able to do that. You can do that in many cases. All right, so we get some information here. We trained a new data prep recipe, so that's what we were talking about earlier, where we take care of imputation and feature engineering, dummy variables, and store that information. So that information is stored with the M object now. We get some more sort of meta information, so we ignored this patient ID column. The package thought that pregnancies look numeric, so it trained regression algorithms. That sounds right.
Yep. We
did random forest and k-nearest neighbors. Those are our 2 algorithms for now. This is the foundation of the package. We're working to put more algorithms into the package. We should have regularized regression in there pretty soon, and XGBoost is on the map. So we'll add more algorithms as we go. And then we get a warning about PHI being contained in this object. So if these were real people, we would want to be careful about what we do with that model's object. So now let's see what we can do with this. So if we just type the name of M, we get some more information, like we saw earlier, about the data we trained on and how accurate the training looked. If we want a richer look at that model, we can do summary of M. And we get some of the same information with a little bit more detail. So we get the performance of the random forest over these different hyperparameter values. Here are the root mean standard error values, the R² values for these, yada, yada, yada. We can do this like I showed on the web page. So if we plot our model object, We get the performance of the models at the different hyperparameter values. I think we can do evaluate of the model. So evaluate is another generic function that works on a bunch of objects in the package. So evaluate gives us 3 standard performance metrics for regression models. So this is root mean squared error, the average error, and the R squared value.
Those are from the best model, right? Because you said you trained like 100 models.
Exactly, yeah. So this pulls the best combination of hyperparameters from the highest performing model. One other thing to note for you machine learning geeks out there is that all of this, when we're operating on the model object, this uses out-of-fold predictions from cross-validation. So we're guarding against overfitting there. So all of these performances, those should be, your performance in deployment, in prediction, should be at the same level or maybe even slightly better than the metrics that you see here from the out-of-fold predictions and cross-validation. So we built in that conservatism here so that you don't think you're going to do better than you really will. And then we can predict. So if I do predictive M, so this returns the out-of-fold predictions for the number of pregnancies for each patient. So this first person in the data table had 6 actual pregnancies. The model predicted that she had 8.36, which is, it's a fair error, but it's pretty remarkable actually that it can predict the number of pregnancies that a person has had at all. I wonder what it's using. What variables do you think might be important for predicting the number of pregnancies that a woman has had?
Based on what's on the screen there?
We've also got these.
Good question. Probably age.
Probably age.
Yeah. Put me on the spot there.
Yeah, yeah, intentionally. Well, we don't have to ask Mike. We can ask the model. So there is a get variable importance function, and that will tell us. Oh dear.
Oh boy. Well, it wouldn't be a demo without some hiccups, would it?
Yeah. So something has gone wrong there, and I don't know what. So it's saying that, yeah, well, you should be able to call get variable importance and get how important each variable was to making accurate predictions.
I'll file a bug request.
Please do.
Bug high.
Bug high. I haven't seen that before. I've used that a bunch, and I've never seen that. We'll have to figure out what went wrong there. Anyway, moving right along. So if we wanted to make predictions on new observations, the second argument to predict is new data. And we pass that a data frame with maybe some new patients that just came into the hospital now. Mm-hmm. For the sake of this demo, I will say, let's just make a prediction on the last row in the data set. So I'm going to pull out the 768th row. We'll make a prediction on that, and that individual had 1 pregnancy. In fact, the model predicted that she had 1.8. So that's how predict works. And then, like other things, I'll come back up here for this one. We can plot predictions by simply calling the plot function on the output of predict. And so here, since this is a regression problem, we get the actual number of pregnancies on the x-axis and the predicted number of pregnancies on the y-axis with a 1-to-1 line. So perfect predictions would be on this line, and we can see how the predictions move around that here.
That looks about like my regression models usually do.
Yeah, the model's having trouble getting traction on this problem, except that for women who have 10 or more pregnancies, the model never predicts that they will have 3 or fewer.
All right.
So it's doing something.
At least doing something, yeah.
It's a hard prediction problem.
Well, with the data you've given it.
With 768 rows.
Yep.
Yeah.
And just the features.
That's sometimes the case, right?
It's a nice
sometimes
reminder.
There's just stochasticity in the process.
Yeah.
There's just randomness that you can't capture in a model. What else do you think we should demo? We're at 29 minutes now.
Yeah.
Anything else?
I would love to see. Why don't we go through it with just one level deeper and say maybe you want to prep your own data, maybe you want to train your own models. Maybe you just want to train one model really quick. Because if you're working with a big data set, I bet that 100 model training thing takes a long time. So what's the way to do it fast?
Yep. So everything looks the same here. So we do prediabetes, our outcome, we'll do diabetes this time. We can say for models, I'll go down to a new line here, we can say just train random forest or just train k nearest neighbor.
Mm-hmm.
And then we can say tune equals false. And tune equals false says don't do all those combinations of hyperparameters, just make a reasonable guess for hyperparameter values and run with that.
Okay. So that should be quite a bit faster.
Should be, it will approach 10x faster at defaults
Okay.
As data sets get larger. And so then if we just type in the name of that object, we see models have not been tuned, but we get the same sort of performance information. I want to try, I'm gonna double down on get variable importance.
All right.
I think it's gonna work with this one.
I think you might be in luck here.
Yes,
Hey,
okay.
look at that.
So get variable importance here tells us that for predicting diabetes, plasma glucose was the most important variable. The second most was about half as important, and that was age.
Cool.
That makes sense, right? And then just to demo this one more time, as all these other objects, we can plot that, and we get a plot of variable importance.
Very nice. Very intuitive. Looks great.
So let's real quickly, I'll show prep data. So if you want to go deeper, you want to control how your data is being prepared rather than letting machine learn do everything for you. Prep data is the function for you. It can do all of these things. It does some of them by default, and it has options for how things are handled. So if you want to take your date columns and you want to generate day of the week and month of the year, you can do that. I think by default we generate day of the week and quarter of the year or something.
Mm-hmm.
You can specify how things are done here. And then once you've prepped that data, you can use tune models to control how training happens. So if you know what hyperparameter values you want to use in training, you can pass those to tune models. If you want to burn a bunch of electricity to make your model as accurate as possible, you can turn tune depth up and train at a whole bunch of different hyperparameter values. Yeah, prep data and tune models are sort of one level down if you want to get a little bit more hands-on.
Still cold at night in Salt Lake. I'm happy to let the computer warm up doing that.
Probably about as efficient as your gas heater. Yeah.
Yeah, probably. So I guess that's kind of the end of our time today.
That's the whirlwind tour. So if you'd like to spend 12 hours on that instead of a half an hour, come to the training it has in September, and we'll walk through all that in much more detail, and you'll get to do it hands-on yourself.
That's a great plug. And then if you want more info on any of the functions or demonstrations that you saw Mike doing, I think he'll send out the code in the newsletter if you want.
I will.
But then it's on the website.
It
It's all
is,
there.
which I think we forgot to mention the URL. So this is at docs.healthcare.ai.
Okay. And doesn't that come up when you load the package as well?
It does.
All right.
Yeah,
So
good
that's
call.
pretty handy. We'd love to see you back. Please remember to like or subscribe to our channel. You'll get updates. You'll see us around next time, and then continue this conversation on Slack. We'd love to get feedback about the package, what's working, what's not working, what do you love, what do you want to see more of.
Yeah, let me just reiterate that.
Go for it.
If you're using Healthcare.ai and there are features that you would like to see, or if there are things that are not working for you, please send us a message. We appreciate some perspective on how the package is being used and what you would like to use it for.
Yeah, there's only, there's 4 of us, so more feedback from people using the package in real environments is really helpful for us.
Yeah, totally.
Thanks.
Yeah.
Hope to see you next time.
Okay, thanks, Mike.